class, we are skipping chapter 4 as of now and moving on to chapter 5. So in chapter 5, we are looking at linear functions. The reason we are covering this first is because once we go back to chapter 4, then we are going to focus on all sorts of different kinds of functions. But getting linear functions down first would give us a nice baseline. Okay, so in lesson 5.1, we're looking at rate of change and slope. Rate of change and slope are interchangeable. They mean the same thing. They have the same purpose. It's just two different ways of saying it. So slope, or rate of change, is the ratio of the vertical change, which we typically call rise, to the horizontal change, which we call run, between 2 points on a line. Okay, so looking at slope and what it actually looks like, we represent slope with the variable m. Okay, like our definition says, slope is the rise over the run. You almost always represent slope as a fraction. Okay, so the rise, like we talked about, is the vertical change, and the run is the horizontal change. Okay, when we're looking at vertical change, the positive is when you move up, negative is when you move down, and with our horizontal change, positive is when we move to the right, and negative is when we move to the left. Okay, one thing that we'll talk about just right down here with the slope formula is slope is the change in y, or the change in your rise, over the change in x. Okay, we refer to y, or our y coordinate, as our rise. Y is always vertical, and our x coordinate as our run. X is almost always horizontal. Okay, so a super important formula that you guys need to memorize for, honestly, the rest of algebra, and if not the rest of high school math, is the slope formula. So with the slope formula, we're looking at two different ordered pairs. We call our first ordered pair x1 and y1, and our second ordered pair x2 and y2. Okay, so slope, which is m, we use x2 and y, or our ordered pair with the sub, our ordered pair x1 and y1 and x2 and y2 to represent our slope formula. So we have the change in y, which is just y2 minus y1, over the change in x, which is x2 minus x1. Okay, so our slope formula is y2 minus y1 over x2 minus x1. This aligns directly with these definitions that we talked about. The change in x, change is when you subtract, over the change in y. Okay, we've already talked about the definition for rate. Remember, rate is when you compare two quantities by division in different units. Okay, so an example like this, we have 3 miles per 1 minute. Remember, this is a unit rate because you are comparing 3 miles to 1 singular minute. When we are comparing things to multiple units, this is just called a, just typical rate. Okay, so we have $30 per 5 shirts, or $30 over 5 shirts. Remember, rates act the same as fractions. So we can divide these and simplify them the exact same way. So 30 over 5, we can divide both of our units by 5, to give us $6 per one shirt. Now that we've simplified this, this has become a unit rate. All right, so the reason we're talking about rates is because really slope, in a sense, is just a rate of change, right? It's just a rate. So when talking about slopes, there's really four main kinds of slopes that are necessary to discuss. Okay? Sometimes you will have a slope that looks like this. Okay? When your slope is moving up or moving uphill, we call that a positive slope. Okay? Conversely, when we are looking at a slope that is trending downhill, we call this a negative slope. Okay? So think about it. When you are climbing up, you are moving positively. We are increasing our altitude or elevation. When you are going downhill or moving down, you are decreasing your elevation. We also have the case where we have just a straight horizontal line. Okay? This, we are not moving uphill or downhill. Maybe my line is a little bit here, but for what I'm trying to show you aren't. Okay? That means that you have a zero slope. You are not changing your elevation whatsoever. You are staying the same, zero slope. We also have the situations in which you have a perfectly vertical line. Okay? In these cases, your slope is referred to as undefined. Okay? Once we start looking at equations, a positive slope will be represented by a positive number. Negative would obviously be represented by a negative number. When we have a zero slope like this, you will see y equals a constant. And when you have an undefined slope, you will see x equals a constant. Okay, now we're going to dive into a couple different formats that we can find slope from. So the first way that we can discover slope is from a table. So a table always has input values, which we will call x, and output values, which we will call y. So in order to find a rate of change or slope, we need to find the change in y over the change in x. Okay, so let's start by looking at our change in x, or a change in our time. So from 1 to 2, we have a change of 1. From 2 to 3, we have a change of 1. From 3 to 4, we have a change of 1. So our change in x would just be 1, and then our unit, which is minutes. With our output values, or our y values, from 260 to 520, we have a change of 260 feet. From 520 to 780, we have a change of 260 feet. And from 780 to 1040, we have a change of 260 feet. So our change in y is 260 feet. Okay, right here, we have a unit rate. So really, we could represent this as 260 feet per minute. And that right there is the rate of change or slope of this situation, which if we wanted to look at it visually, we could graph this as well. That is very possible. Okay, so really, especially when we have a linear function, you can write your rate of change directly from a table, just like this. Okay, pretty straightforward. So another way that we can find slope is from a graph. Okay, so finding slope from a graph, really the first thing you need to do if you don't have a graph is plot your points. In the examples below, this is already done for us. The second step is we need to find the change in y. Which is our rise, or our vertical change, and we need to find the change in x. Which is our run. Or our horizontal change. So you'll find the change in your y values, find the change in your x values, and then you have to make sure that you simplify your answer all the way. The reason we simplify, we'll see more once we start graphing, but it's important to get in the habit now. So in these first couple of examples, we are going to look at them strictly graphically. Okay? We are not going to use a slope formula or anything like that. We're just going to look at it graphically. So here, in this first example, let's find the change in y. So our vertical change. So to go from a y value of 5 to a y value of 3, we change -3 or down 3. So in this case, our vertical change is down 3. And then looking at our horizontal change, which is the change in our x values, from -3 to 4, if you were to count, -3, -2, -1, 0, 1, you can tell that we are just moving right 3. Or sorry, right 4. My bad. Okay, so if we were to write this as a slope, we would have m equals the change in y, which is down 3, or -3, over the change in x, which is right 4, or +4. So we can write our slope directly from there. On this next graph to the right, we'll follow a very similar process. First, let's start by looking at our change in y. So we start with -3 and we end with 4. So to go from -3 to 4, we have to go +7, or if we're looking graphically, we will move up 7. Then looking at our x directions, to go from 1 to 2, really, the change is only +1. Or graphically, right 1. So if we were to write this as our slope, we have m equals the change in y, which is up 7, or +7, over the change in x, which is right 1, or +1. Okay? Remember, we have to always simplify this. So if we have 7 over 1, that simplifies to just a slope of 7. In our last example here, we have a different looking line. Okay, this is one of those special cases. First, let's look at our change in x, or in y, sorry. So we go from 3 to 3. So obviously, you can tell that we aren't moving up or down in this case. Yet, if we look at our x values, we go from -5 to 2. Okay, that obviously has a change of right 7. So when writing our formula, or writing our slope, we have m equals the change in y from 3 to 3, which is 0, over the change in x, which is right 7, or +7. 0 divided by 7 is just 0. So in this case, we have a slope of 0, which is just a horizontal line. Okay, one key detail that I forgot to mention is if you are finding slope strictly graphically, always start with your furthest left point. Okay, this will just help with the consistency of your process here. All right. So in order to keep the video within a reasonable amount of time, I'm going to skip these next two examples, try them on your own, and then once we come to class, make sure to remind me to start with both of these, and we can just look at finding slope in a variety of different ways as a nice review. Okay, the last thing that we need to cover here is finding slope using the slope formula. Okay, this is probably the most important way that you know how to find slope. Okay, just a reminder, our slope formula is m equals y2 minus y1 over x2 minus x1. All right, so looking at both of our examples, we are given two sets of ordered pairs. So within each ordered pair, our first order pair is our ones. So we have x1 and y1. And then our second order pair, we have x2 and y2. Okay, so writing out our formula here, we have m equals y2, which in this case is -8, minus y1, which in this case is 5, all over x2, which is -7, minus x1, which is 4. Okay, let's go ahead and simplify this. This equals -8 minus 5, which is -13, all over -7 minus 4, which is -11. Remember, when you have a fraction, it's the same thing as division. If we have negative over negative, that does make a positive slope. So -13 over -11 can be simplified as 13 over 11. Which is the slope between these 2 points. All right, example 2. Let's follow the same exact process. So remember, we have x1 and y1, and we have x2 and y2. Okay, let's substitute these values from our ordered pairs into our formula. So this gives us y2, which is 9, minus y1, which is 0, over x2, which is 5, minus x1, which is -2. Remember, when substituting in your negative values, make sure that you put parentheses around them. Okay, this gives us 9 minus 0, which is just 9, over 5 minus -2. That turns into addition. So we have 5 plus 2, which is just 7. Check to make sure that you can't simplify this. 9 over 7, we could not simplify that fraction. So we have to leave it as our slope. All right. So hopefully that gave you a good introduction to slope and rate of change. I know we covered a wide variety of methods during this lesson, So make sure, if any is unclear to you, that you take note of it and then ask it in class. Okay? Thanks for watching.